Okay, good afternoon to all of you. Today I will give the topic of op-amp. You know, op-amp is nothing but operational amplifier. It consisting of two words. One is the operational, another one is the amplifier. That means the op-amp is the abbreviation of op-amp is nothing but operational amplifier. So what do you mean by operational? Operational is nothing but which is performing some mathematics operation like addition, subtraction, multiplication, integration, division, etc. That means if the device can perform using this mathematical operation, that is called as operation. And amplifier, as we know that amplifier is nothing but it is a device which is used for the purpose of amplification. So what do you mean by amplification? Amplification is nothing but the process of raising the strength of weak signal to high signal. Suppose if you want to strengthen the low signal to high signal or converting low signal to high signal, we are using a process. That process is called the amplification. For the amplification process, which device is used, that device is called the amplifier. So when if you are using the amplification technique helping of mathematical formula, you are boosting or strengthening the low signal to high signal, then we can say that device is called the operational amplifier. Got it? Operational amplifier is nothing but it is a electronic device which is used for the purpose of strengthening the weak signal to high signal. Then coming to the next topic, symbol. As we know that every electronic device have a particular symbol as per their abbreviation or as per their significance. So like that op-amp have 5 terminals. So first terminal is nothing but inverting terminal, or we can say inverting input. Second terminal or second input is nothing but non-inverting input, which indicate the positive side. VCC, positive bias supply, VEE, negative bias supply, and the final one is the output, which stands for V0. So according to the symbol, the op-amp have the 5 input: inverting input, non-inverting input, positive bias, negative bias, and output. But in some time, in application, when you are using that application in the field of application, sometimes the two op-amp it may consider as a single input. It may consider as a single input, but overall the op-amp have the 5 terminal: inverting input, non-inverting input, positive bias, negative bias, and the fifth one is the output terminal or output input. This is the symbol of your op-amp. The next concept is your, we can say after the definition of op, then one is the symbol of op, then we can go in for the ideal op-amp. We can say the ideal op-amp. The name itself, ideal, as we know that sometimes if you are having the ideal is special characteristic, ideal is special difference. So what do you mean by ideal op-amp? See, we know that we are having the op-amp having the 5 terminal, input terminal, 2 input terminal. One is the inverting, which are having the negative sign. One is the non-inverting, which are having the positive sign. 2 supply, positive bias supply, negative bias supply, and fifth one is the output terminal. So according to the symbol of the op-amp, we are getting the ideal op-amp. That means if the difference between the 2 input terminal, if the difference between the 2 input terminal is 0, suppose that means this is V1, this is V2, okay na? This is the differential voltage, okay na? This is negative input, this is non-inverting input, and this is the output terminal. So suppose this is my inverting input and this is my non-inverting input. as we know that when we are applying the when we are using the op-amp in a practical cases, we may use the single input. So for that, if the difference between the two input terminal, that is Vd is equal to 0, then that cases we can say the op-amp is the ideal. So understand, if the difference between the two input terminal V1 minus V2 is equal to 0, or we can say Vd is equal to V1 minus V2, which stands for 0. That is called as the ideal op-amp. Then next is your op-amp characteristics. See, every electronic device have a different characteristics. Like that only, op-amp having also characteristics. According to the characteristics, the op-amp also performing its operation and application. So, what are the characteristics are there? As we know that the op-amp having the 6 characteristics point. We are having the op-amp having the 6 characteristics. So what are that? We will go through one by one. That is the gain input voltage gain is infinity. That is the gain of the op-amp is infinity. What do you mean by gain? Gain is nothing but output by input. That is called as your gain. Gain stands for total output by total input. That is called as your gain. So op-amp have always the infinite voltage gain. That is gain is equal to infinite. Then second one is your zero output resistance. Zero output resistance. Zero output voltage. Third characteristics is your zero output voltage. Infinite CMRR, common mode rejection ratio. CMRR stands for common mode rejection ratio. So whenever we go through the parameter of the op-amp, then I will be telling you details about the CMRR. What is CMRR? Means common mode rejection ratio. So just for that time you know that CMRR nothing but the differential gain by common mode gain. That is nothing but AD by AC. That is called as CMRR, common mode rejection ratio. That I will tell you the detail. We have to go through the what is CMRR, how we are calculating the CMRR in log. Okay, na? What are the formulas are there? How we are calculating the CMRR in the op-amp? We have to go through the detail when the topic will come the op-amp parameter. So infinite CMRR, infinite input resistance, infinite input resistance, infinite output resistance. So these are the 6 characteristics of the particular op-amp. That means the op-amp is working according to these characteristics: infinite voltage gain, zero output resistances, zero output voltages, infinite common mode rejection ratio, infinite input resistances, and infinite output resistances. These are the op-amp characteristics of any op-amp. Okay, na? And I forgot to tell you the op-amp is invented, okay, na, in the year 1947. The scientist C. Regioni invented this op-amp. Okay, we are mostly the op-amp we are using in the laboratory purpose, particularly in the electronics laboratory purposes, and mostly the op-amp invented 1947. That the IC number is IC 741. Remember this. This is the IC number of the laboratory op-amp. When we are using the laboratory op-amp, we can say blindly the IC 741 is mostly used in the laboratory purpose, online purposes, and this IC 741 is invented in the year 1947. The scientist, or we can say the electronic scientist C. Regioni, okay, na, invented this. According in this year, we have got the first IC of the op-amp, that is nothing but IC 741. Okay. The next topic is your application of op-amp. See, before that application, I have to tell you the parameter of op-amp. I have to tell you the characteristics of op-amp. Okay, na? After the application, I will tell you what are the parameters and what are the characteristics. But for that time, you have to know we are having the op-amp having the two characteristics. One is the AC characteristics and is your DC characteristics. And coming to the point of op-amp parameter, almost 10 to 12 points are there, okay, related to your op-amp parameter. So the next classes or my next video I will tell you that, but for the time we have to know the application. See, every electronic instrument, as for the requirement, we are using the field of various applications, because we know that op-amp is the most widely electronic instrument for the use of laboratory. So for that we are using that op-amp IC741 in the lab, particularly in the analog and the basic electronics laboratory purpose. According to that use of that IC741, what are the applications are there of the op-amp? The first application of the op-amp is nothing but inverting amplifier. First application of the op-amp is inverting amplifier. Second application is nothing but non-inverting amplifier. Third one is your integrated. Fourth one is your differentiated. Fifth one is your summer. Sixth one is your, you may say instrument, but for the time etc. are there. So we have to go through as per our syllabus. Mostly these 5 applications we are using in the field of laboratory purpose: inverting, non-inverting, integrated, differentiated, summer, etc. So each video I will explain you individually one by one, because every application has some numerical solution or mathematical derivation, as well as that block diagram, as well as that schematic diagram, as well as that the numerical solution. So each application will be take one video. Okay, na? So for that I will go for the classes I will tell you just brief introduction regarding this individual application of the op-amp. So what will be inverting? See, just for the time you remember, inverting application, inverting amplifier is nothing but here the phase shift is 180 degree. The phase shift of the op-amp is 180 degree, and the inverting input, that means the inverting input is nothing but which is connected the negative sign of the op-amp. So that input will be function other than the non-inverting input will connected to grounded. I will show you the details using the schematic diagram or the symbolic diagram. Similarly, non-inverting input, here the non-inverting input is connected to the supply voltage, whereas the inverting input is connected to the grounded, and it is the reverse process of your inverting amplifier. Third application is nothing but integrated. So integrator is nothing but it is a electronic device, or we can say which is used for the purpose of integration mathematical integration purpose, or you can say if you want to derive the value of the integration, we are using that integrator. That is nothing but the third application. Differentiator, fourth application is nothing but differentiation purpose. If you want to differentiate between the two input voltages, we may use the application of the op-amp. Fifth one is just summer. If you want to more number of input transmit simultaneously at a time, if you want the number of input connected to the supply voltages with the help of inverting concept, then that is called as summer. So finally, what you know over the application of op-amp is nothing but which is related to your mathematical purpose or mathematical application. As I told you the definition when I started the op-amp application, op-amp topic, I told you it is used for the operational amplifier. That means the mathematical operation, and using mathematical operation it will be boosting the signal or strengthening the signal from low level to high level. That's what this is called as an operational amplifier. So these are the application of the op-amp: inverting, non-inverting, integrated, differentiator, summer, etc. The next video I will tell you one by one what is inverting, what is its block, what is its schematic diagram, what is its mathematical derivation, how to solve, what is its phase shifting, how the phase shift is working, which terminal is connected to grounded, which terminal is connected to supply voltage. That I will tell you the detail. Like that, non-inverting, integrated, differentiator, summer, etc. Thank you.